Hey there, ladies and gentlemen. This is Mr. Deacon. As you know, I will be out of town for the review days before the test. So what I'm going to do is I'm actually going to record myself creating the answer key to the practice test that you guys will be getting on Monday. So without further ado, let me get myself out of the corner here. Oh, there's the bell. Cool. So first step. The whole top part here, we have some Pythagorean theorem type problems. So for the first one, I have rad 5 squared plus something squared. I'm going to call that x. That's going to equal 5 squared. So when I do some arithmetic here, rad 5 squared is just 5 plus x squared equals 25. Now from here, I'll subtract 5 from the other side, so x squared equals 20. Now, when I write this, I know that my answer is going to be the square root of 20. However, I don't like leaving it as a radical, okay, unless I can simplify it. So if I break this down, we have 4 and 5, 2 and 2. Oh, I see a pair of numbers. So this turns into 2 rad 5. Next one, let me go ahead and group some of this up, get it out of the way. Here I recognize this as a 30, 60, 90. They have given me the long leg of the triangle. So I'm going to label this long leg. Well, if I wanted to get the short leg, I have to take the long leg, which is 14, and I have to divide that by rad 3. I really don't like the way that looks, so I need to tack a rad 3 to top and bottom. That's called rationalizing. So my final answer over here for my short leg is going to be 14 rad 3 all over 3. Once I know my short leg, my hypotenuse is going to be twice as big. So 28 rad 3 all over 3. Boom, done. Number 3 is going to be very, very similar. So I'm going to go ahead and take a look at my 45, 45, 90 pattern. They give me the hypotenuse. If I want the legs, I have to divide that number by rad 2. Again, I run into the exact same issue. I don't like having a rad 2 on the bottom, so I have to simplify that by multiplying rad 2 to top and bottom. Ooh, not rad 6, rad 2. I goofed. My apologies. So this turns into a 6 rad 2 all over 2. Well, that can simplify because I'm noticing 6 over 2. That's just 3 rad 2. Boom, done. On to the next one. Actually, first, let me go ahead and shrink all this valuable info a little bit further down and off to the side. So all that is still there if you need to refer to it. Okay. In which quadrants will theta lie if cosine is less than 0? That's a fancy way of saying that it's negative. And tangent of theta is greater than 0. That's a fancy way of saying positive. Well, if I think of my pattern of all students take calculus, I know that cosine is only positive in quadrants 1 and 4. So this thing has to be negative then. That's not what I wanted. It has to be negative in either 2 or 3. And if tangent is positive, well, that can only happen in quadrants 1 or 3. So clearly, the overlap here is in quadrant 3. Next up, naming the reciprocal of sine, that would be cosecant. And the reciprocal of cosine is secant. Remember, when we do these, each pair will have one word that starts with an S, one word that starts with a C. All right, finding the trigonometric functions, it's a tongue twister. Trigonometric functions that pass through the point -1, 3. Well, hey, right off the bat, they gave me an x and a y. That's pretty awesome. -1, 3. If I were to plot that, I know it's going to be somewhere over here in quadrant 2. I don't know exactly where, so that looks about right. Sure, why not? Drawing my triangle. -1, 3, boom. Now, unfortunately, this is not a special right triangle pattern. I really wish it was, but it's not. So that means I'm stuck doing some Pythagorean theorem. I've got 1 squared plus 3 squared equals something squared. Well, 1 squared is 1, 3 squared is 9. Add those together, I get 10, so this guy's the square root of 10. And that's going to be my R value. So the sine of theta, again, theta is going to be this angle between the x-axis and the terminal side. Sine of theta is the opposite side, 3, over the over the hypotenuse, which was rad 10. I don't like the way that's written, don't like radicals in the bottom. So after I rationalize by multiplying top and bottom by rad 10, that's going to turn into a 3 rad 10 over plain old 10. That can't simplify any further. To get the reciprocal function, I'm going to take this 3 over rad 10, and I'm just going to flip it to a rad 10 over 3. Now, I could have, if I really wanted to, I could have taken this guy and flipped that, but it wouldn't have really made much sense because then I'd have to rationalize and do more stuff. So we're going to go ahead and avoid that. All right, onto the cosine. Well, that's adjacent over hypotenuse. So just like before, we're going to take our adjacent side. In this case, it was -1 over rad 10. We don't like the way that looks. Rationalize it. We'll get negative rad 10 over 1, or just negative rad 10. That works as well. For the secant, if I, I completely screwed up, guys. I'm sorry. I gave you the secant value. All right, let's try this again. If I were to rationalize for cosine, that'd be negative rad 10 over 10. I got a little ahead of myself, and for that, I am sorry. All right, tangent. Opposite over adjacent, in this case, 3 over -1. If you really want to, you can call that -3. It's the exact same thing. Cotangent, we're going to flip that, so -1 over 3, 1/3. Bingo, bango, bongo, done with that one. Onward. Okay, so this one's given us a handful of stuff. Cotangent of theta is 5/12. And it terminates in quadrant 3. So that's a big bit of information. I know that my triangle is going to end up down here. Now, if cotangent of theta was 5/12, so that means tangent of theta would be 12/5. Well, hey, that's a free answer. Cool, I'm all about that. So if we know one, we know the other. It's a buy one, get one free. BOGO, gotta love it. Well, I know that tangent is opposite over adjacent. So that logic tells me that the opposite side is 5, the adjacent side is 12. These are both in quadrant 3, though, so it's really a -5 and a -12, since we're down there in the third quadrant where the x's and y values are always negative. Also looking at this, I'm thinking to myself, ding, 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 we got a special pattern, 5, 12, 13. I just saved myself some work on Pythagorean theorem, so I'm all about it. All right, so sine is going to be the opposite side of the hypotenuse. In this case, -5 over 13, and that's a freebie answer for its reciprocal, 13 over -5. Cosine is adjacent over hypotenuse, -12 over 13, which gives me a freebie answer for its reciprocal, 13 over -12. Draw on a better negative sign. And that, my friends, is how we got all 6 trig functions. On to the back side. All right, they're telling us the secant is 17/15. Well, secant is the reciprocal of cosine, so I know the cosine is the reciprocal, 15 over 17. And that's going to help me figure out that, hey, we've got an adjacent side and a hypotenuse side. Now, cosine was positive. So right here, they're telling us that we have a positive 15 over 17. So if I think to all students, take calculus, We're talking either quadrant 1 or 4. So it's either quadrant 1 or 4, one of those two. The next portion here says that sine is greater than 0. That's a fancy way of saying positive. Well, sine is positive in quadrant 1, but it's negative in quadrant 4. So this thing has to land in quadrant 1. So ding, ding, ding. This is our winning quadrant. Now I can label all of my sides accordingly. If I know the adjacent and I know the hypotenuse, I can give this some labeling. The adjacent was 15, hypotenuse was 17. That means my opposite is going to be 8. That's a special right triangle pattern. If I didn't remember that, I could always use the Pythagorean theorem. So now my cosine is going to be the adjacent over the hypotenuse. Well, that's 15 over 17. Sorry, that 5 kind of looks like a 3. Eesh. Let's fix that. Not much better, but all right. The tangent is opposite over adjacent, so in this case, 8 over 12. Why did I write 12? What am I doing? 8 over 15. Sorry, kiddos, I am losing my marbles, I tell you. All right, and we're scrolling. Next up, we're finding the exact values of sine of 60 and cosine of 40. So we have two options here. One, and don't laugh at my lack of artistry here, is if we're cool with that left-hand method. So I'm going to try my darndest to draw a hand. All right, that's pretty terrible. You can laugh at that. Where we have 0, 30, 45, 60, and 90. We could always go ahead and just do that little shortcut to find these. Or my other option is if I have the side ratios all memorized for 45, 45, 90s and 30, 60, 90s, I can go ahead and get these ratios the same math. So first off, sine of 60, again, either using the left-hand method where I put down my index finger, or I could use the triangle up here. I'm going to see that the sine of 60 is going to be opposite over hypotenuse. So that's going to turn into rad 3 over 2. Cosine of 45, that's going to be my triangle over here on the right. That's going to be the adjacent over the hypotenuse. I don't really like having a radical on the bottom, so we throw rad 2 up top and down below to give us our final answer of rad 2 over 2. Boom, boom. Last and final one. Whew, made it this far. How long should an escalator be if it is to make an angle of 30 degrees? That's important. With the floor, and carry a vertical distance, that's important, of 21 feet. Scooch that down a bit. Between floors. Using the information, create an equation, round our answer to the nearest tenth. Oh boy. So I've got an escalator. Fancy, 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 fancy. Carrying people up a vertical distance of 21 feet. So anytime I see vertical, that's an indication we are going straight up and down. I know that the angle is 30 degrees here. Well, hey, then by default, this has to be 60. Oh yeah, I got myself a 30, 60, 90 triangle. Today cannot get any better. Holy moly. So I know that my hypotenuse is going to be twice as big. So up here, this is going to be 42 feet. And I know my adjacent side is going to be 21 with a rad 3 attached. So 21 rad 3 feet. But this thing is saying, hey, we want this rounded to the nearest tenth. So from here, all we're going to have to do is throw 21 rad 3 in decimal form. Which, let me grab a calculator because I cannot do that in my noggin. 36.4 after rounding feet down there. So these were the two bits of info that we have found. That's it and that's all. Good luck studying. As always, shoot me an email if you're stuck.